Hey! Hey! I'm Mr. O, here with another
Oh wow!
moment at the Children's Museum of Houston.
Avery, you have to check this out. It is so cool.
Let me try. Oh wow, the marker doesn't work on that one.
Did somebody say, oh wow?
I did. The marker ink doesn't work on this one, but it does work on that one.
Well, that's because this one is painted with a special anti-graffiti paint. It's made up of nanoparticles that prevent ink and other paints from sticking to it.
Nano? I remember something about that from science class. Isn't it a prefix that means a billionth?
Exactly. The prefix nano in science does mean a billionth, 1 out of a billion. To give you some perspective, look at these very tiny little grains of sand. Now imagine a billion of them. Would it fill up this cup, this pitcher, this bucket? What about this box? Actually, these are all too small. It takes this whole column to hold 1 billion grains of sand. So 1 billionth of this column is 1 individual grain of sand. When we talk about nanoparticles, we're talking about things that are very, very small, nanometers in size. A nanometer is a billionth of a meter. This is a meter stick. If I broke this into a billion pieces, that would be a nanometer. To give you an idea about how small this is, a virus is about 70 nanometers long, a cell membrane is 9 nanometers thick, DNA is about 2.5 nanometers wide, and fingernails grow at about 1 nanometer every second. Nanometers are small. So with the anti-graffiti paint, these very tiny particles have been made to prevent both water and oil-based liquids like inks and paints from sticking to it.
So if we paint this clear anti-graffiti paint on the wall, then no one can ruin it because the paint or ink can't stick to the nanoparticles?
Exactly.
Wait a minute. If nothing can stick to the nanoparticles, then how can the nanoparticles stick to the metal or any other surface?
Well, that's where some clever chemistry comes into play. Pretend that this represents the nanoparticles. The nanoparticles are created by chemists with 2 ends to them. This larger end would represent the end that would repel water or oil, and this smaller end is what sticks to a surface. So when you paint on nanoparticles, the ends that are supposed to stick to the surface stick to it, leaving the ends that repel the oil and water facing outwards. Once dry, they stay that way so that when someone tries to put on ink or paint, the nanoparticles prevent it from touching the surface and sticking. Let me show you a different example. Before we begin, remember, science is fun, but it can also be dangerous, so always have a responsible adult helping you.
We're exploring sand coated in nanoparticles.
For this experiment, you'll need sand from the craft store, water, droppers, trays, and sand coated in nanoparticles, typically sold under the name magic sand, which you can find on the internet.
First, pour the normal sand and the magic sand onto separate trays. Next, trace patterns into the sand. Finally, drop some water onto the 2 sands and watch what happens.
The water gets absorbed into the normal sand.
But the water sits in big drops on the magic sand.
Cool! We can even tilt the tray and make the water follow the patterns in the sand.
Similar to the anti-graffiti paint, the magic sand is covered in nanoparticles that are hydrophobic on one end. That means they repel water. But to get them to stick to the sand, the other end is hydrophilic. That means it likes to stick to water or to things that also stick to water, like sand. Try experimenting with the 2 sands and see what different properties they have. Similar technology is being used to coat touchscreens on smartphones and tablets to help them stay clean. By the way, if you're wondering how to separate your water and sand, it's actually pretty easy. Pour all the nano-coated sand and water into a cup. Rubber band a filter over the cup. Then pour the water out through the filter, leaving just the nano-coated sand behind to use another day. You can do the same with the normal sand, but it will need to be left out to dry. This has been another oh wow moment from the Children's Museum of Houston. We hope your mind can come out to play.